Okay, folks, let's get started. It is my great pleasure to welcome Matt Beane, an old friend of mine from the days when we were back at MIT, like so many other folks in this room. Matt does field work involving robots and AI to uncover systemic exceptions that we can use, positive exceptions we can use across broader world of work. His award-winning research has been published in top management journals like ASQ and Harvard Business Review. In 2012, he was selected as the human-robot interaction pioneer. I think that means that you were the human part of that. In 2021, he was named Thinkers 50 Radar List. Matt's an assistant professor of technology management at the University of California, Santa Barbara, and a digital fellow here at the Stanford Digital Economy Lab, and also at MIT's initiative on the digital economy. We welcome and encourage questions during the seminar. If you're in the Zoom audience, submit your questions using the Q&A function in Zoom. For those of you here at Stanford, raise your hand and there's mics around. We'll just wait for the mic and we'll give you a chance to answer the question then. So with that, Matt, welcome to Stanford, and please tell us about engineering skill.
Thank you, Eric, and thank you, everybody. This is a not yet submitted paper, and so your feedback matters a lot more than normal out there in digital world. And here you will see that as evidenced by the slightly modified subtitle here on the paper. So live fire exercise. Let me give you a brief overview of me and my work. You can think of me as someone who does work that is focused on how we deal with technology at work and how organizations respond. That's the bottom of the y-axis there. And the top is sort of a lifelong, really, obsession with skill and how we build skill at work, and the confluence of those things. So there are a few papers in that domain. I'll just put these all up here. And the other axis is intervention in the world to produce effect. So I have discovered I have a moral agenda and want the world to be a different place than it is right now. And particularly as it relates to skill and work and technology. And so some of my work is more focused in trying to provoke and study the change associated with those things. Today's talk sits squarely on the upper left-hand part of this diagram. So this is a paper about the implications of complex technology and work-related processes for how we build skill. The book is, I will only mention now briefly, I have a book coming out in June. This is a trade book meant for popular audiences. There's a QR code there for folks who are interested later. That'll take you to a website where you can learn about the book, subscribe to my Substack and all that. That's the end of the commercial. And now I'll move on to some scholarly content that I'm really looking forward to your feedback on. So in one slide, thanks to Abhishek Nagraj for this genre. I think it's hopefully quite useful. If you have to leave at the end of this 40-second bit, you will get the entire story of the paper. I'm not going to summarize this for you, but just sort of for your edification, I'll walk you through all of these sections. What's the motivation for studying how non-professionals might build skill in collaboration with professionals? Bottom line, we have a massive skills problem in the economy, and a lot of it has to do with the challenge of moving from a non-professional type sphere of work and the skills associated with that into work that requires more complex skills that are better respected and remunerated by our society. There's a lovely paper here, the Al-Abdul Karim paper in 2018 that sort of characterizes this barbell and the cost of traversing that barbell. So, and it's particularly problematic because if you're a non-professional, you really lack a bunch of resources that normally would allow you to build skill and move into a higher paying and more societally respected job. You really only have the performance of your job as ground zero, a place where if you do your job and you build career enhancing skill in the doing, you can get ahead, but extracurricular options, i.e. school, take money and time, and you don't have those things. That's the basic problem. If you look at available research, it looks like any contact time with professionals as a non-professional is caustic to your pursuit of career-enhancing skill. So there are lots of studies in the professions and occupations literature that show, for example, that, just to pick a few off the top, professionals will hive off the dirty, dangerous, or dull parts of their work and give them to non-professionals because they don't want to deal with them, and those are not a road to success. In fact, those are a road to stagnation for those people. And also, in general, separation of professionals tend to separate their work practically from non-professionals and so on. The research on technology and organizing shows essentially that as technology is an intensifier to these negative dynamics. So there's, of course, an entire literature on de-skilling, right? More automation equals slow, workers below the waterline, so to speak, losing skill over time the longer they remain. It intensifies the issues above, right? And there's one lovely exception I want to call your attention to. This is a very recent paper by Marjolaine Rostaing and Ruth Ann Husing that shows machine operators learning how to code their machines just by vicariously hanging out with the technicians that program them. And they sort of learn some troubleshooting ability, but also basic ability to read machine code. That's the only exception I could find. In general, the research on non-professionals and professionals in technology-infused work shows this other effect, which is basically the longer you hang out with a professional in a work context, the less rich your opportunity space is for developing career-enhancing skill. There's certainly no study I could find that shows by collaborating with professionals in work involving technology, you enhance not just skill, but your career. You get better job, wage outcomes, and so on. And that is what I think we have our hands on in terms of this study. The firm, by the way, I should say, the firm often wins in these studies. So you will see lots of workers, some recent examples too, workers participating in a work process in a way that enhances output, relies on their ingenuity and so on, but they don't garner any direct benefit, but the firm's productivity is maintained, or professionals' productivity is maintained. That's key to mention. So I think that's nuts. There's a lot of other studies, work, and I've summarized this here, that basically says that when we're not focused on skill development per se, that shows wonderful boons to being around professionals if you're a non-professional, right? So and reasons why we might expect non-professionals to at least sometimes build skill in these contexts that enhances their career. So the quick way of looking at the top three, say, of these bullets is that non-professionals see stuff professionals don't. That has to do with their role in the work sometimes, like they can actually see empirical phenomena and characterize it that professionals can't. But their disciplinary orientation, prior education, and life experience allows them to encounter and name and intervene in phenomena that professionals are literally invisible to professionals. We also have this very rich literature on workarounds, basically, that shows that non-professionals are the glue that makes automation stick for the first chunk of time when it's deployed. If you look under the hood, I mean, the popular version of this these days is to see workers behind ChatGPT and robots making things work and so on. But there are also many cases where on production lines, good old-fashioned kind of conveyor style physical production, workers on the ground that get paid very low wages who are non-professional are doing things reliably to ensure the productivity of that line that are not noted or remunerated by anybody with power in the system. Nevertheless, we have lovely studies that show that. And I've just published a piece last year that shows that in that, the doing of a workaround repeatedly, you build skill. It's not just you've learned this trick. The word learn sneaks in there. You built some capability. That study didn't show skill accumulating to non-professionals. It was professionals in my case. Anyway, the last thing to say, Steve Barley always has the beginning and the end word on all questions around technology and organizing, in my view. He had a lovely piece in 1988, an essay, in which he basically said the de-skilling literature looks really convincing until you look at what it looks at. And it looks in conditions that are particularly generous to its point of view. In other words, you would expect to find de-skilling in the places that those papers go looking. So I took that essay. I'll give you the inverse example. The inverse example is I went through his 88 essay and I said, all right, what conditions in what conditions would we expect non-professionals to build career-enhancing skill as a result of collateral interaction with professionals? And here are those inverted criteria. So for instance, a new site and new hires. In In previous studies, we have large bureaucratic organizations, and non-professional workers are stuck in a system that they really can't perturb. Well, in a new site and hires, in a process you follow over time, where they are committed to the firm as opposed to cogs at the firm, and so on. I'm not going to rip through all of these, but essentially, this is the sort of set of conditions that Barley in '88 predicted that you should go look in if you want to particularly, it's to look in conditions where it's particularly likely to find a positive, skill-enhancing outcome for a non-professional worker. And we have an empirical context that literally matches all of these. So these are enabling conditions. I think you'll see the dynamics we find in our study in other contexts. It's just they're going to be particularly evident and easier to study. So the context here is so you were looking at the performance of two robotic systems doing the same warehousing type tasks that we studied last years. There's the end of that sound. One of those had a human supervising it, the other did not. It's those supervisors that are the non-professionals that are the focus of this study. And this is a sort of orienting quote. If you had to take only one piece of qualitative data here and sort of build a story around it, this would be it. An engineer from this company that we're calling JointBot says, so this is the idea of how does the thing get better over time, the same being the system. It's a system, right? But the system includes humans. So it's the humans who work on it, and it's the humans that operate it. The union of their work is the success of the robot. So I'll give you a bit more about the empirics now. JointBot was one of a number of robotics firms in our sample over the last ending about a year ago. We had about 3 years of data studying 8 firms like this, deploying AI-enabled robots across warehousing firms of a variety of sizes and compositions around the US. This was comparable to the others in terms of size. The basic premise of its founding, though, was, at least in the beginning, one non-professional worker controls one robot remotely to get its job done. And the idea was to scale that to 1 to 2, 1 to 4, 1 to many, which they accomplished. Over 3 years is our data collection period. We also started to realize they had and then asked for and then received millions of records of all of the interactions between those workers and their robots on a very, very fine-grained level. We barely deploy that data here, and we have LinkedIn data for those people. So that's to sort of set the stage around the data. And here's that qualitative quote, just substantiating the point that I was making earlier. In case you are not familiar with qualitative work, I don't want to assume anything about the audience. Basically, any quote-based sort of qualitative data that I'm offering here is an instance of a class of data that supports that point. So any claims that I make related to one quote, it's not as if we have one quote there. We wait until we see saturation on that theme and only present themes where the data is just sort of uniform on that point. So you can assume we have quite a bit of data. To set the stage on the empirics, these drivers controlled the production task of the firm. They didn't build, obviously, the ML behind the hood, under the hood that made the robots go, so to speak, but they were the ones initially controlling it. And they shared control not contemporaneously, but they and the professionals involved both occasionally controlled these robots remotely. And these folks had a wide variety of experience, and as they used the robot, now we're all somewhat familiar with this story, they produced training data that allowed the ML under the hood to automate that task more and more effectively over time. And so you can go from this one-to-one to one-to-many relationship where the firm went. And here's a recruitment bit of data. So this is one of these people that they called drivers. So Marty and I, we both started back in August of 2017. It was very weird. The job was noted on LinkedIn as, do you like video games? And now my skills and experience are definitely beyond that. But of course, if someone's asking me if I like video games, I'm obviously going to be like, yeah. So anyway, none of these people were professionals in any domain related to the job functions in the firm. Now I'm going to throw some of this human-robot interaction data at you. And the reason that I'm showing this to you now, let me give you a quick description of it. You have the timeline for the firm and part of our sample across the bottom. You have two types of people controlling and supervising robots. On the left-hand side, professionals, and then these drivers. And I'm just showing you this now to show you that you can see there's a significantly greater number of professionals controlling these robots than drivers until these curves cross about 2/3 of the way through our sample. But then you'll see many more non-professionals controlling robots than professionals, but they both stay in the loop. In other words, they both sort of got their hands on the controls throughout the study period. And this is the firm's growth, sort of the number of orders is that curve that's superimposed there. I'll come back to this style of data in a moment. You'll also, if you're reading carefully, see across the bottom, we're sort of moving from one-to-one to one-to-many control. You'll get another chance at this. Now, the skill development story for these non-professionals is essentially grounded in solving problems in their workflow and for the firm, and doing it collaboratively with professionals. So there's no way I have time to go through all of these. So the blue ones are the ones that I'm going to highlight and give you data to show you the story as to how these drivers were initially sort of drawn in by professionals to help solve problems to do with making the automation better. And then eventually those drivers became much more proactive about approaching professionals with problems in subsequent phases. The 3 phases of automation development in this study match almost every other firm you could imagine out there. You have a prototyping phase where their system basically really sucks. Then you've got a revision phase where they're approaching product market fit, but they still have considerations and difficulties to work out. And then a scaling phase, right? We've essentially got a solution that works. Now it's time to get many customers. That's where those curves crossed in that graph that I just showed you before, that chart that I just showed you before. So let me move to arms that don't work. So given that both professionals and non-professionals shared this task, they would discover problems together and resolve them. So here's an engineer in the firm who used to be a driver. This is a sort of foreshadowing of the career enhancement outcome. He says, as a driver, you start seeing failures where the part that attaches to the gripper of the arm starts to break often, and we don't know why. And the drivers, can point out, oh, well, it's sweeping across the bin and hitting other items. And we, engineers, don't see that. Then we, on the mechanical side, look at the load analysis and be like, all right, yeah, this is part of the flange, or the connecting point's a little weak. Or the AI motion side be like, okay, when we pick the item, let's pull out better and then pick up the next routine. And this is all, however, a gift from the Driver Foundation. These are people who cite these problems and make them legible to engineers. This kind of allowed for more rapid iteration on design. So this is somebody who manages a pool of drivers. He said we would have skeleton shifts on the weekend where it was 3 drivers, 20 robots, and they were swapping and swapping and swapping their attention across robots. And so that was a major, major driver of ML engineers trying to move as quickly as they could, because we're like, shit, we're killing these guys. We've got to make this thing smarter and faster. In other words, they had daily contact with these drivers, empathized with how difficult the job was just to control these robots, and wanted to automate, not to serve the customer, but to help their buddies out and make their job easier, to scale their attention. Here's just one instance of a driver now, these drivers beginning to proactively share problems with professionals to engage them in problem solving. This is a driver who said, I'm sitting there and clicking a button all day with something called this, they had a system internally called the bot interpretation prompt, or BIP. People hated BIP. I know for a fact that people would take a weight and put it on their keyboard because right would mean yes, and so it wouldn't block the robot. This is a system that the driver was prompted to say, does this look like a good grasp? Or is this the edge of an object? And the system had gotten so good at this point that it was just useful just to hold down the spacebar and say yes all the time. And so the drivers finally told engineers this, and the engineers fixed the problem. The engineers said, let's start getting the computer to do it. In other words, label those images automatically, unless we need those people to do a specific labeling project where we're looking for nuance, and they could take their time with it instead of being something that's literally blocking production. Because as that system was built, until that robot gets that, yes, that's the edge of an object, it won't finish its grasp action. So that's why those drivers would hold down the spacebar, because they knew that customers' goods would not be moved if they sat there and verified an image. So the engineers shunted these drivers' attention to the more nuanced and complicated strategic image labeling issues through software. And they also did the same for more complex physical control problems. So here's an instance there. If we were all of a sudden grasping hard goods, in other words, new customer hard goods, there would be some incremental learning we need to do with a really experienced driver, say a deodorant. They're notoriously difficult to grasp. What's the right way and location? You stand it up. Some of those data points will be learned by the algorithms, but they're also not, they're going to have to be learned by driving, and it's not for every item. It'll just be, okay, what's the tricky one with these new set of items we just took on? So engineers built systems to redirect drivers' attention to novel, challenging, complex problems and let the automation handle the stuff that it had learned to handle. So while the automation level, so to speak, of the systems might look relatively constant, it was it looked that way because it was directed towards problems that were known and well concretized in the algorithms. And these workers, these drivers, were continually oriented to deodorants, kayaks, and winter jackets, and so on. Okay, drivers during this prototyping phase began to become more proactive. So, and it would accelerate design. I have an engineer here saying, I design it, and based on their feedback, I'm like, dang, well, that was stupid. Why'd I do that? And it's a humbling idea. And you become a better engineer because of it. In other companies, you don't get the feedback. I enjoy that quite a bit. The professionals involved came to rely on and appreciate this grounded, sort of at the coalface kind of feedback from non-professionals. And it resulted in a variety of positive outcomes, both for non-professional skill. So I'll just quickly highlight here, these drivers learned complex robot control. They learned a bit about robot and AI design, development, and function just through interaction with these folks, and also about UI and UX. Remember, they're complaining about their user interface for labeling all these images or controlling the robot. And as they issue complaints, they see feature adjustment and so on. And they learned a lot about those processes themselves as a result of many months of interaction and so on. The automation itself improved. So then we have the revision phase. Now, this is where the robots are more or less effective, and we're well past the point of one driver to many robots. I'm going to highlight two problems here that non-professionals were more proactively involved in naming and then getting solved. One was the robots were effective on task, but not business level effective. They weren't producing enough throughput at enough quality for a business to want to buy at scale. And there were technical trouble when these systems were deployed. So you remember, this is one remote worker controlling a robot doing a physical task hundreds of miles away, right? So in the building, as the robot was functioning, there is inevitable technical trouble, and there are only workers nearby who are not technically trained and don't understand these robots. So there are difficulties there that are notable to the controller of the robot only. First off, it's important to note that I've reinforced this once already, but professionals would, when they received problems from these drivers, they would proactively resolve them. So this is a driver naming a new problem for a professional to solve. The driver says, we created terminology as we were driving. Me and another driver, we were like, let's call them dead zones. These are areas in the bin where they're sorting objects, where the arm could not, I guess, understand how to rotate its joints. You know what I mean? This has to do with the kinematics of the robotic system. There are things called singularities in a robotics movement where it can't articulate its joint and so on, and so or without damaging itself. And so in order to move through those fluidly, these drivers both discovered where these dead zones were in the space and then called them dead zones, named that as a code-worthy problem to the engineers, and it entered the backlog for those of you who've done software development work. Engineers did not notice that, and then they would prioritize these problems to resolve them for throughput and productivity. So here's a driver saying, when the arm stowed an item, in other words, put it where it was supposed to go, it would only go back to one waypoint in the space. We were like, is there any potential to create more waypoints? And the engineer said, yeah, like, oh yeah, we put that on the back burner. Are you sure you want to bring that up? And me and the other driver looked at each other and like said, yeah, just enable it and we'll test it. And we did, and it improved. I think we went from 100 to 250 units per hour just based on that. So this, just to visualize it yourself, there's a space in which the robot arm could move. And if it could stop at a waypoint that's closer to this set of bins, workers knew that the next order was liable to go over there, so they could it allowed for more economy of motion, this much more economy of motion. This was advocated for, identified by, and then drivers only, and then solved by engineers. This is the kind of productivity enhancement that got this firm more customers, right? In the course of this kind of joint problem solving, there's yet more rich opportunity for these drivers to develop skills. So here's a driver, again, this is in the revision phase, saying, we learned from these system escalations, the problems we were seeing and ferrying to our engineers. We'd say, hey, what is going on here? Why is this thing broken? Why is this part of the system not working? What does this mean? Being able to understand how our engineers were diagnosing these issues, how they were responding to them to keep the robots back online, and over time, us picking up and assimilating that knowledge. And there's a lot to learn from that kind of process of osmosis by which we all became experts in the system. If they had this much contact every day, dealing with issues from customer sites and so on, this is the kind of outcome that you might expect. This gets to one of your earlier points, Eric, about what are those conditions where we might expect things to go well? A long-term interaction with your counterpart, high-frequency interaction, complex problem solving, where both parties have data to contribute. This is the kind of result you might see. So just to point a fine point on what this skill was that these drivers were building, because you might question its value. This is a driver manager saying, we had some very proactive customer-focused drivers who felt comfortable answering a support call in the middle of the night, explaining the more technical aspects. So if an engineer calls and wanted networking issue questions answered, they were able to answer those. So they kind of naturally expanded into that role. Maybe they were already doing that. It's only been recently where we formally recognized the different tiers and the levels they were working. So this gets at the customer site trouble resolution. You have people, engineers, customer engineers, trying to troubleshoot these robots. And the only person up at 2:14 in the morning is a driver. And some of them were willing to answer questions. Yeah.
So can you say something about the motivations or incentives for the drivers to do this? I mean, at 2 in the morning doing this work might be easier to just kind of chill and not be like trying to help the company. I mean, it's a good thing to do. Maybe is that a friendship? What are their motivations for putting in that effort?
Right. So we don't have a counterfactual for that. But what I can say is that all these folks joined sort of early in the startup's trajectory and they answered an ad about video games. And they realized, I'm joining a stealth startup building robots that are going to move stuff around in the warehouse. This is to one of those selection criteria. They identified with the firm. In other words, they felt lucky to be there. They felt like this was really cool. And they felt like they were part of a team at a ridiculous kind of nosebleed level for their expertise. And so it became kind of cool to help with the technical development.
One thing I've heard in other contexts is sometimes workers are worried about making the firm more productive because it might lead to loss of jobs. Like if it's, one of those examples was 2 or 2.5 times as productive. Yes. I assume that didn't lead to 2.5 times fewer people, but I'm
about to show you a graph. In fact, the opposite happened. So we had a big spike in hiring of these kind of people. But I think at this point in the game, it's a legitimate concern. This firm its robots were not that great, didn't work all that good, and they were trying to acquire customers. So there was a lot of upside yet to be achieved. So making everybody that much more productive was so important that at this point, we have no data of anybody citing a concern at this point. But you would expect that in this kind of an environment, right? So we can talk later about generalizability of these kind of findings. In other environments, I might expect something different. The latter phase of the data collection, I'll talk about in a moment, conditions start to switch a little bit. And I think we see some more of that, actually. That's a nice, helpful contrast with this data. Here's the key part of what enabled, and I think this is one of the core findings of the study, enabled this to happen at all, which is that drivers had quite a bit of slack time to deal with projects that they decided to deal with. So a driver says, so one person spends 2 hours driving, the other guys are clicking, and we shift. That's throughout an 8.5-hour day. Other things we could do during that time would be any side projects related to our own areas of interest and skill, actively monitoring our systems. So I'm going to take you back to some of this data, and I think Eric will speak to your point. Now, this is the driver sort attempts and professional sort attempts. This is the number of times somebody in the driver role was trying to move an object using a robot and the number of times a professional was. right? And you can see the professional numbers going significantly down over time, driver numbers going up. But the main thing to notice here is that the peak shift and off-peak shift lines are the max number of hours a driver is supposed to work in a day. These curves underneath that line is how many hours a day they were actually controlling robots across this time. So the area above that line is how much free time these drivers had. Quite a bit. In some cases, they had 70% slack time. And as time went on in development, they would take on, they would do some things like monitoring systems, but a lot of them would just take on elective projects to try to help in areas that they had identified that they were interested in building skill. And professionals, of course, contributed much less over time. And a number of these drivers transitioned into professional level roles in the firm over time. That will show up later in the data. So, and we count these here, but even at, allowing for that effect, you have quite a bit of slack time for somebody in this entry-level role with no professional background. So this should be an old theme by now, but this kind of slack time, especially as the firm progressed and people developed their skill, allowed for much more focused and rather extensive development and deployment of skills that go way above the non-professional level. So this is a driver later in our study saying, so I'm open to any design work, whether it's UX, UI, or just kind of marketing material or other random things that need to be done. I made a brochure that sticks onto the robot that kind of gives it a brief training to people who aren't familiar with it, and the digital side of redesigning the image labeling system, making it more user-friendly, because that's designed all by software engineers and it works well for them, but it's not always obvious to the actual drivers. These are 3 elective projects requiring UX, UI skill, requiring marketing-related skill, graphic design skill, and so on, all of which this person did in a pinch. Startups are notoriously resource thin. It was just a way for that person to help out in an area they wanted to develop skill and had developed some already. This is also partially a function of professionals and non-professionals spending much more collaborative time on comparable tasks. So a driver said, every morning we do stand-up. This is a standard software development genre meeting with all these other teams. I remember looking at the other driver each day and saying, like, are we doing this? Are we actually carving out what this product is eventually going to become? Because again, we insert an ad that said, you like video games, which is nuts. So you can think of a prototypical sort of Scrum meeting with ML engineers in the room, mechanical engineers, electrical engineers, system engineers, product development people, and drivers in a software meeting, contributing potential features, bugs, and so on, much as any other team member would. Different people in different roles in the hierarchy started to notice this. So this is a driver manager who was once a driver. He said the more and more we built our team, we started noticing these emerging skill sets. We're like, we can all contribute something even additional to this company. And that follows through with the kind of me now like managing a team of drivers. This person had a high school diploma, was a driver, and now is managing a team of these people. Again, I'm not going to go through all of these things. There's a raft of specific non-professional skill that we show in the paper that was developed by these folks as they started to take on more and more. And then for the firm, they got new features, they got better system performance, better customer responsiveness, because these drivers were taking customer issues and doing essentially technician work. But in short, no one individual, of course, developed all of these skills up here. But many of them developed one or more areas of these skill and moved into roles that allowed for it. Scaling is this key moment where the conditions change a little bit, which I do think reveals the sort of limits to this happy skills utopia. It's a particularly conducive space for non-professionals to be building skill. Product market fit happened for this firm, right? This is why you scale. Once you have a system that works, that's reasonably reliable, you start to go try to get many, many customers. That's what happened. And about this moment in that data, they insourced manufacturing to a Central American facility. So they were outsourcing their building of their robots before. And they took driving and moved the sort of pure driving work down to Central America, and the more advanced customer-facing driving work kept it in North America. Right? So The interesting question here is,
Sorry.
yeah.
What's the difference? I mean, isn't all the driving customer, like, what's the pure driving? How is that?
Customer-facing driving is the work where, in addition to just supervising, say, 20, 30 robots, if there's somebody on site who has a technical issue, they can enter it into a paging system, and you'll be the one to respond to that engineer or worker who's got an issue with a robot versus I just control the robot, right? I'm just looking for exceptions, and I'm essentially a data labeling contributor. I'm something a little bit closer to what we're traditionally used to thinking of as the person behind an LLM who's labeling text or images and so on. However, for both kinds of drivers, this volume of slack was preserved. But these drivers down in Central America were no longer directly exposed or physically proximate the software development team working on the AI that automated the system. They were, however, physically proximate to the mechanical engineers who were there to build the physical system. That was their new domain of potential skill expansion, much less the digital side. But it was less. So the incident management and so on, issues and so on, and software development side of the ML all stayed up at sort of headquarters North America. And Central America had much more to do with optimizing build and making the robots efficient. The Central American drivers also didn't initiate projects anymore. They were responsive, but they were repeatedly drawn into not just their driving work, but the mechanical engineering work of making those robots more efficient and reliable. So I'll just give you one instance there. This is a driver in Central America saying, so we're like mixed in because sometimes the ones that work on the manufacturing team, they come here to drive, and sometimes when some of the drivers are needed for anything like mechatronics, we send them to the manufacturing team. So there was a rotation of work opportunity that occurred for these folks. And they still jointly solved complex problems, but they were restricted to the manufacturing domain by and large. So here's a driver saying, so back in the beginning, when we started shipping robots, we were scared about the unit getting damaged. Those old cubbies were like so flimsy, massively expensive, massively crazy. So we took off the cubbies. It was just like a naked robot. We do secure them for them not to wiggle in the van, and now we can ship 5 in one truck at much lower cost instead of 1. So this was a 5x reduction in ship costs for the firm, and this was an idea that came from one of these drivers. We had somebody who spoke Spanish who was embedded down there for a little while. So still significant gains for the firm, but also learning about process efficiency and build design and so on. They had no more side projects, these drivers, but they were still involved. So this is a driver manager saying, what I learned about the team over there was they had immense amount of feedback regarding things that we can improve systems that they were observing. And I went there and I'm like, oh my God, they have great ideas. However, management had to go there and ask for those great ideas. The drivers in Central America were no longer readily and proactively suggesting design ideas for how to change things, except for their physical counterparts there, mechanical engineers. Yeah.
Was there also a language issue, like Spanish versus English?
Everybody involved in the workflow, engineers, process folks, product people, all were bilingual by and large. And I assume to some degree that occurred, but at least there's nothing in our data that indicates any of their counterparts of these Central American drivers had any issues. And certainly all of them spoke. Okay, so yet again, there's skill development here. It's of a different intensity, somewhat lower positive intensity, but still these Central American drivers, just by operating the system, were learning about robot and AI design and functioning. They had collaborations with people across sites. So now with headquarters and also with customers occasionally, they're learning to manage large fleets of robots, but in particular, learning about manufacturing of complex robotic systems. This improved design, iteration, and speed to a good, cheap product for the customer on the manufacturing side by. So here's the key moment that occurred actually during the revision phase that I'm bringing up now because this is about careers and the legibility of these skills in folks' careers. There was several points at which drivers' roles were sort of fractured into a number of types, some of which were customer facing and so on, involved higher level skill, UX design, all the rest of it. And these were explicitly renamed so that they were externally legible. So a driver manager, this is someone who started as a driver, again, think high school diploma, no previous applicable skill. He said, so product support specialist is, I'm proud to say, a term I came up with. This is the eventual title for the higher level driver. They were originally going to call them customer service technicians. And I was like, no, they are product support specialists because they can put this on a resume and go anywhere else with that, and it's going to look far more impressive. They were performing the skills and performing the aspects of the job that matched very well with that title as understood by the wider job market. So this is not a sort of bait and switch with respect to that title. It's actually faithful representation of what that job is. But it was a driver themselves who suggested this title. Management adopted this title. So there was product support specialist at the top, driver 1, driver 2, but all these were eventually renamed such that they would make sense on LinkedIn, so to speak. And in fact, they did. So we have data. I could go back to one of the charts if you need, but you may have noticed at peak, there were a total of 44 drivers in the loop working for the firm, starting from 2. So that workforce itself grew. 21 of them were on LinkedIn, and as best we can tell, that number is spread across all dimensions you might wonder about variance. Central America, North America, prior education, and so on. It's just that some of these folks were on and some not. 16 out of that 21, so 76% during our study period advanced into professional level jobs. So product manager, data analyst, technician, internally or externally. It turns out 9 of those, so that's 42%, were outside the firm. So these people got product support specialist jobs in other firms. 4 people, one of them you saw on a slide, 19% of those 21 were in a new, without a new engineering degree or certification, moved into jobs that typically require such credentials. So they had a title, electrical engineer, inside the firm, and had no original training in that regard, so that they had sort of worked their way up to performing that job function within the firm. We have qualitative data that corroborates this pattern for those that were not on LinkedIn, so to show that this is the general trend. Here's a snippet. This is from Central America. The manufacturing manager there said, we didn't have to hire externally for manufacturing. We just pulled people from driving. The good stuff is that they know how the robots work, right? Because they're involved with it on the operational side with the customer. So they'll know that stuff to check on what things the robots will see in the field. These guys just come in and adapt real quick. So there was a much more straightforward route for these people to enter into professional roles in the firm, but then also externally as they acquired these titles. The way I see it anyway, the core contribution of this work is to say, we've just been looking in the wrong spots if we want to see what it might look like for non-professionals to build career-enhancing skills as they collaborate with professionals. We picked a particularly opportune space. I think, however, the mechanisms that we uncover are liable to show up elsewhere, just in less florid form. The first is you have professionals and non-professionals doing shared performance of that core production task. This is not building the ML, this is controlling the robot to do a job, versus them having strong occupational task segregation. The next is you need slack time, and you need those non-professionals taking advantage of that slack time to proactively engage with problems. So if non-professionals have no slack time or very limited slack time, you're not liable to see this, I don't think. I think that's one of the implications here. And the last is, to the extent that people with power, typically professionals, engineers, but it could also be leadership, direct these non-professionals towards strategic complexity. This is in the beginning. Am I just going to have you label all images or just images of weird stuff? And then eventually it's, am I going to let you focus on UX, UI projects, or do I just want you to continually control robots, and so on? The extent to which those non-professionals have ready access to a wide range of complex, strategically relevant problems to solve, they're going to build more skill because no one else can notice them or solve them. And so that's, I think, what the difference was with Central America and North America. Central America, this was much more restricted. You saw less development in that regard. Thank you. It's the end of the data.
Thanks.
Welcome to your feedback.
Questions? Sure, let's go.
Thanks. Very interesting. I had you showed this graph where we saw this increase in orders, and I thought that's quite interesting. You also mentioned that there was this kind of 2.5% productivity increase. And I'm just wondering to what degree there. You mentioned one could be driving the other. I'm just wondering because I think the time frame is something like 14, 15 months. So what kind of mechanism do you have in mind? Like, is it like the firm? I mean, you can only order as many orders as you have, right? So, I mean, is the firm able to drive prices down that much over that period that it can actually triple the orders, or what kind of mechanism do we have there?
Up close, it's very difficult to parse those things. I'm trying to get back to that first graph. We have lots and lots of words to get through. Here we go. Yeah, so this hockey stick moment where the firm starts to grow, a lot of the sort of going from 150 to 200 or 100 to a 250 units per hour kind of eureka moment happened in this revision phase, which is right in the middle here, before the hockey stick moment. So a lot of it was, at least in the case of JointBot, I don't know if this will generalize, the operational reliability and throughput of that system was proven out. And that is what allowed it to scale. That is what allowed them to pursue customers at this greater scale and so on, at least in this case. But I'm not sure. I would need another data set to sort of adjudicate on, I think, what you're asking.
I was asking, I mean, this is orders coming into the firm, right? I mean, how was the firm?
That's orders process. In other words,
just process. Okay.
Yes. And by the way, orders is not the B2B order. That's the order received by the customer, let's say some retail outlet, the customer ordering a jacket and a pair of shoes that the robot handles. So this is a number of customer orders that the robot is sorting. If that makes sense.
Thanks.
Okay.
Hi, Matt. This is fascinating. Thanks for sharing. My question has to do, it's a question and I don't have an answer for it. So open-ended, totally, about how do you think about the physical collocation, the proximity? Because you have three groups of actors, the non-professionals, the professionals split into mechanical engineers and AI engineers. And then you have, of course, the machine itself. So how does that play into the conditions that you're trying to tease out of this story for optimal conditions for developing the non-professional skills?
Yes, I think we don't have the data, strictly speaking, to answer that question. I thought a lot about that one. I've had other people say, okay, so is this back to the sort of within 30 feet rule about learning and so on? It's not, we can't say. It's certainly not one of the core enabling conditions of the study, because there are Central American drivers who do build skill to do with digital stuff and so on. They just tend to be outliers. And vice versa, right? So there are drivers in that original phase where the manufacturing, this is not a useful slide for me to stop on. Let's get to the end one way or another. There. We also have drivers in the beginning who sort of are more mechanically inclined, and it seemed very clear in the data that they went out of their way not to be involved in digital stuff and to track down mechanical engineers who were physically seated ways away. It's a super intriguing question. And I think we would need a new study really to get at that very clean.
Yes, can you hear me?
Yes, I can hear you.
Yes, I would like to come back to this idea of slack time
that
the drivers or professionals have. Now, doesn't the business have the incentive actually of keeping them busy as much as possible? And actually, if they have some slack time, we should intensify to keep them busy with other tasks. Not so much a task that the drivers or the professional chooses, but actually the task that the management is using.
Right. And up close, in principle, yes, sort of a rational orientation on the management as an effect in organizations, you'd presume that. Up close, this is much more co-constituted at the level of sort of the sprint backlog, like what items make it on that sprint backlog for the dev team happens out of a Scrum meeting. And the drivers and the professionals are in that meeting. And the only thing that actually gets into the log is something that the engineers decide is worthy of the time. So it's not as if the drivers get to decide, oh, let's just do this stuff over here. The engineers are the ultimate deciders on what the feature set is and what the backlog is and what's the top priority item. It's just that drivers' suggestions often made it into that list. And so those side projects they got to do them, but only because engineers and professionals agreed to that and saw it as strategically relevant.
So are you making a recommendation that they should be offering those opportunities to professionals that they can hear? Or are you just making a statement of fact that it works like this in some places?
So this is an extreme case, right, where these things are pretty exaggerated. I would expect it to be more attenuated elsewhere. So that's one. Two, we would need another study, an experimental, like a field experiment kind of study, in order to test, like, is this provocable intentionally? Because this was all when we asked them, do you realize you're cultivating these non-professionals into professionals and so on, and this is a great career opportunity for them and so on, right? I waited until late to provoke that because I didn't want to mess up this dynamic. But it's not obvious to me that this is a method that one might implement in the world, or that's even desirable. It's just more revealing dynamics that are useful to understand that might be happening elsewhere. More work required to figure out, like, when and how could you do this intentionally? Would it work? Under what conditions? I don't know. I see multiple questions. Maybe we can go here and then back to Arvind. Yeah.
There seems to be kind of an element of vocational training even here. Vocational training.
Yeah.
And so, people being upskilled, more committed to their company, and even finding new positions within that company. Then again, where's the training in here? Because it seems to me that it's rather the kind of drivers that are actually training the engineers and the managers. So what's your take?
There was no formal training by or for anyone at this firm during the entire study period. Even towards the end, a driver would get hired in Central America and another driver would just sit with them. There was no material, there's no formal classroom training or anything. It was all moving too fast. It was a startup environment. So yeah, formal training didn't play a role. But yes, I agree. They were constantly training each other, learning from each other, and so on. Yeah, we're focused more on the non-professionals. We could actually show what the professionals learned as a result of this. That would be interesting. I think we have the data to do that. Arvind, I saw your hand back there.
Thank you, Matt. Fascinating study. So my question is, back to your initial question on the conditions under which reskilling or upskilling happens, right? So one sort of a cynical way to look at the data is the firm, say from a purely software engineering, product engineering perspective, is using the drivers to collect data on the exceptions. And then so could you talk a little bit about what conditions does it happen? Is it during very early stages of product development and maybe very, very early stages of scaling, and after that it doesn't happen? Or what is your sort of hunch?
Yeah. So there is a version of reality, which we've seen this at numerous companies, all of us, I think, now that we're all aware of this issue, that it's possible to hire that workforce, train your AI to a base level, and then don't hire more of them and make sure they continue to do highly monotonous, soul-crushing work. Like, that's the modal way of handling this if you involve users in the entry-level people in the control loop at all. So it's not inside the bounds of our data, but I think from a naturalistic generalization point of view, there are firms out there that do the evil version of this, or the sort of low road, right? So their imperative was growth, and they were trying to consume new customers with very new problems associated with their items and so on. And so keeping a human in the loop and sort of directing their attention to those novel problems consistently, there was always this upward spiral of new customer problems to solve. And so you had to grow that workforce and keep them focused on the complexity. Otherwise you die, because they had to saturate in the industry. What happens after they saturate the industry and have reliable automation across all known e-commerce retailers and so on? It's an open question. I could see a change. I wouldn't be shocked.
Where you would observe such a thing.
Oh, all right. Hello?
Yes.
Oh, yeah. Awesome. Also a question about conditions and where you would observe such a thing. I'm curious about the startup environment as like inviting people to stand-ups, being resource scarce, and wanting to get drivers involved in the process. Is that a relevant part of the story? Would you expect to see this in a...
Yeah, I think of all of those, the conditions that I listed on that slide, and thankfully there's a recording, those are all enabling conditions. In other words, they make these outcomes There are more of them. They're more intense and more intensely positive than you would expect to find in many other cases. However, I think we should expect somewhat comparable but reduced dynamics like this in many other places. If non-professional workers have slack time, if they share a core production task with professionals, and if the tasks or problems they're focused on are strategically relevant and complex, that could happen inside a large bureaucracy. I think that would be a very interesting study. It would probably not be as awesome as this, right, for the entry-level worker, but maybe it would be. I don't know. I think the complement study would be to go to a very highly a government or something that somehow had those three characteristics still evident for a non-professional worker and see what happens to their skill then. But that's outside the bounds of the study. I don't know.
So I have a question. So a lot of these people wanted to and did successfully upskill to being more professional. One time when I was visiting a factory, I was very surprised. Everyone in this room probably likes being a professional. That's why we're here. But when I was visiting a factory, we were teaching them statistical process control, and I was very excited about all the standard deviations and Six Sigmas and stuff. And I was surprised that most of the factory workers were really not interested in learning these new skills,
right. And
they preferred their job without having to do a lot of this complicated math and other stuff. And I'm curious whether, clearly there's a set with 70+% that went on this path. Were there others that actually really were happy to be doing the driver type work and were not aspiring to become more professional?
Most definitely. I think what's interesting here is that everyone was nudged towards this higher maximum when it came to skill. Like some workers, in fact, who did build extracurricular skill and were advanced, were not having fun, right? They would have preferred, like, just give me my job, I'll do my job. But they were summoned because they had expertise on why this robot couldn't grasp object B. And whether you like it or not, you're coming to this Scrum meeting because we need you to tell us. And so in some cases, we just don't have enough data to sort of treat on that separately. But it's not as if their preferred way of working got honored either, because it was all hands on deck. We have to make this thing better. So if folks have more discretion about whether they get involved, larger organizations say, I bet many, many workers who did end up with career enhancing outcomes here would not get them because they weren't. You would think that all the folks who were upskilled and got ahead were somehow hoping for that and pushing for it. To the contrary, some of them kind of went kicking.
And you probably didn't observe any of this, but were there any, like, even professors who went the other way? I mean, occasionally you hear about a B-school professor decides to go open a bed and breakfast or something, but was there any move in the other direction?
It's sort of downhill, so to speak.
Professionals, like people deciding, like, I don't want,
Professionals deciding I want to just go cut lawns or something?
Or be a driver,
No.
Yeah.
Not in our data set. Anyway, they all had equity.
Okay. Maybe time for one more quick question. Yep.
Yeah. So I was wondering if you would frame this as like a general upskilling story, or would you frame it as like they develop like firm-specific human capital and now they upskilled in this specific firm, but can they actually apply this like to different firms, or can they only handle this specific robot? Because if you compare this to like a degree system, they are trained to handle this problem generally. And
if they only stayed with their driving job, it would be firm-specific capital. Maybe some UX UI understanding that would be relevant for other similar tasks. However, all the upside sort of value-added activity they engaged in around improving UX UI and so on, and that they did, that was all externally legible. That's why these folks got external jobs, because they ended up with titles and skills and bullets for their resume that were applicable for jobs that were at least 1 or 2 pay grades above. So if they had stayed where they were, they could only stay.
Okay. Well, I'm afraid we're out of time. That was amazing. Thank you so much, Matt.
Pleasure to be here.
And I'd like to invite you to come back on April 22nd when our speaker will be Dan Hedricks talking about AI and evolution. So see you all then. Bye.
Thank you all.